Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. Well, in this case we are going to compute a confidence interval for the difference between two population proportions. In that case, we have two groups of patients that they have been applied to different methodologies in order to know if the illness improved or not. We have a first group of 200 patients, from which 25 reveals an improvement in the illness. In the case of the second group of patients, we have 100, and it seems that 10 of them are recovering. So we have two proportions, 0.125 and 0.1. That's 0.1. So we can compute the confidence interval that is going to be centered in the different proportions, and we're going to subtract the theta value of the normal 0,1 that led to the left side probability of alpha divided by 2, multiplied by the standard deviation of the distribution. In that case, this standard deviation is the square root of the sum of variances, the variance of each of the proportion distributions. In that case is p sub a multiplied by 1 minus p sub a divided by n sub a plus p sub b 1 minus p sub b divided by n sub b. This is equal, so this interval, the probability is going to be equal 1 minus alpha. If we apply this to our data, we have that the difference between proportions is equal to 0.025. The value in the normal 0,1 that led to the left side, a probability of 0.025 is minus 1.96, and the standard deviation, if you substitute directly your population proportions by the sample proportion, you have a standard deviation of 0.038. So the final interval will be minus 0.0484, and the upper bound will be 0.09948. As the lower bound is negative and the upper bound is positive, we cannot be sure with a 90% probability that one of the methodologies is going to be better than the other.